1B reads, a pitcher threw a baseball straight up at 24.8 meters per second. What was the ball's velocity after 2.5 seconds? Note that although the baseball is still climbing, we're accelerating it downwards. So in other words, don't confuse negatives and positives. Okay. So the only number that's actually given is what? 24.8. Okay, meters per second. Quantify that. Oh right, also given time. My bad. So time is easy, but 24.8 meters per second. So meters per second gives away that's velocity. And which one is it? Velocity at the start or at the end? That's your VI. What are we trying to find? Our VF. Okay. So now it's actually not too bad. So let's go ahead and crank this puppy out here. Okay. Step 1, make a little sketch. Here we have a baseball player. They take a ball, and all they're doing is they're throwing the ball straight up. So let's be. As it goes up, it speeds up or slows down. What do you suppose? It's going to slow down because what? Gravity is accelerating it downwards. Okay. So our knowns and unknowns: speed, distance, and time. Okay, no SDT. Right? Bad. You want to do stuff like what? VI, VF, A, right? Delta X. What else? Time. We have 5 knowns and unknowns. Okay, that's kind of a secret. You always have 5 when it comes to constant acceleration problems. Yeah. Just breaking them all down. On this one, we were given the initial velocity is 24.8 meters per second, like we just said. At a time of, what was it, 2.5? That's what we're trying to get, right? How fast is it going? That's our unknown. We can't quite solve this because in algebra, you can only have one unknown, right? And in each of these equations, there's 4 variables. You need 3 out of the 5. You can solve it. So there's a freebie. Where's the information? You can assume that you play baseball on what planet? On Earth. Welcome, we come in peace, right? So accelerate negative what? 9.8 meters per second. And we don't know delta x, but we don't have to solve for it. So in fact, let's just put a box around what we need to know. So now we look in our what? Our toolbox, okay? Let's go to our toolbox of equations. Where's my toolbox? There's my toolbox. It's one of these suckers here. In our toolbox of equations, we want to know VF, we know VI, we know A, we know T. The first one, let's use it, okay? You know what? Sometimes you're like, I don't know which equation to pick. Don't panic. There's only 4 equations, right? So try one. If it doesn't work, pick another one. But eventually you'll get good at figuring out which equation to use. All it is whichever relates to knowns to unknowns. In this case, VF equals VI plus AT. Expand my equation. VF equals VI plus AT. And then we'll substitute and solve, okay? Step 4. Final velocity is what I want to know. Initial is 24.8. Acceleration due to gravity is negative 9.8 meters per second every second for 2.5 seconds. So now I'll just get out my calculator and I'll plug and chug. Watch for order of operations, okay? This will be 24.8 plus, in parentheses, there we go, negative 9.8. Oh, there we go. Times 2.5 seconds, okay? And I get, should the ball be going faster or slower as you throw a ball up? Should be slower because it's slowing down by gravity, okay? So it's like 0.3 meters per second. In other words, I'm almost at the peak. It's positive 0.3. You add in a 0.0, okay, for my sig figs there. Meters per second. Slowing down there. Got it? Actually, 0.3, yeah, good enough. 0.30 meters per second. Nutshell, that's 1B.